Hello friends, welcome to Internetworks. My name is Edgar C. Francis. In this video, we are going to see the special feature of BGP Allow-AS. Well, BGP Allow-AS feature is to allow the BGP routes to accept the routes with its own AS number in the AS path attribute. Remember, there is a risk of creating loops if not managed properly. I suggest you to understand this Allow-AS feature. You can check the link in the description box. I have wrote everything about this topic clearly. See here, I have wrote everything about this topic in this blog. The risks, the best practice, and using scenario, functionality, purpose, and what is this BGP Allow-AS feature. So this is our lab. You can see over here we have couples of router and switches. We are going to first we have to configure the IP addressing as per the topology. After that we configure eBGP and iBGP protocols, and we verify that the 10 dot network and the 50 dot network in the router 5 and router 1 routing table. After we configure the BGP Allow-AS feature in the router 1 and router 5, we ensure that the route 10.1.1.1 and route 50.1.1.1 in the router 1 and router 5 routing table. Okay, in the end we ensure that the connectivity with the ping and the trace route command. So starting first we have to configure the IP addressing. Okay, so let me start this router console. Okay, so we have the two networks. Okay, interface, serial, and 4/0 IP address, which is 12.1.1.1, 255.0.0.0, no shutdown, exit, and another one is fast Ethernet 0/0. Okay, it's the Ethernet. So Ethernet 5/0, and IP address is 10.1.1.1.1, 255.0.0.0, no shutdown, exit. Now switch to router 2, configure terminal. We have two serial interfaces. So serial 4/0 and the IP address is 12.1.1.1.2, 255.0.0.0, no shutdown. And another one is interface serial 4/1, IP address is 23.1.1.1.1, 255.0.0.0, no shutdown, exit. And interface fast Ethernet, it's a Ethernet 5/0, IP address is 20.1.1.1.1, 255.0.0.0, no shutdown, exit. Okay, now switch router 3. Router 3 having two serial interfaces and one fast Ethernet 4/0 and 4/1. Okay, configure terminal, interface serial 4/0. The IP address is 23.1.1.1.2, 255.0.0.0, no shutdown, exit. And interface Ethernet 5/0, IP address is 30.1.1.1.1, 255.0.0.0, no shutdown, exit. And another one is serial 4/0. The IP address is 34.1.1.1. So interface serial 4/0, IP address is 34.1.1.1.1, 255.0.0.0, and no shutdown, exit. Okay, now router 4, configure terminal, interface serial 4/0. The IP address is 34.1.1.1.2 255.0.0.0. No shutdown, exit. Another one is serial /1. The IP address is 45.1.1.1. So interface serial /1. The IP address is 45.1.1.1 255.0.0.0. No shutdown, exit. Okay. Now in Ethernet 5/0. IP address is 40.1.1.1. No shutdown. Okay. Now router 5. Configure terminal, interface, serial 4/1. IP address is 45.1.1.2 255.0.0.0. No shutdown. And interface we have Ethernet 5/0. IP address is 50.1.1.1.1 255.0.0.0. No shutdown. Let's verify. Do show IP interface brief. Okay. We have the serial interface up and we have the Ethernet up. Okay. Let me verify this router 1 also. Do show IP interface brief. Okay, 12 up and we have the Ethernet 10.1.1.up. Okay. Now we configure eBGP and iBGP. You can see the AS number is 65100, 200, 300 and AS65100 again. Okay. So we are going to configure eBGP and iBGP as per the topology over here. Starting with router 1. So router BGP 65100 and we have the neighbor which is 12.1.1.2 and the remote AS is 65200. Okay, and we have the network 10 dot, so 10 dot, and the mask 255.2.0.0.0, and we have the serial network which is 12.0.0.0, mask 255.0.0.0. Okay, no synchronization and exit. Okay, now we are going to configure the eBGP and iBGP on this router 2. Okay, so router BGP 65200 and we have the neighbor 12.1.1.1.1 and the remote AS is 65100, which is this router 1. Okay, and again we have the iBGP neighbor which is 23.1.1.2. so okay, 23.1.1.2 and the remote AS is 65200. Okay, you can see the neighborship is up between this router 1 and router 2. Okay, now we have to configure, advertise the network which is 20 dot, 12 dot and 23. So first 20.0.0.0 and the mask 255.0.0.0. again we have the 23 and 12 dot network, so 12 and 23. No synchronization. Okay, now router 3. So router BGP 65200. Can see the router 3 is in a AS65200. So, and we have the neighbor. We have one IBGP and one is EBGP, which is 23 and 34. Okay, so 34.1.1.2, and the remote AS is 65300. Okay, this is the 65300. So 65300, and we have the neighbor, which is IBGP, which is 23.1.1.1, and the remote AS is 65200. Okay, now we advertise the networks. So networks is 30.0.0.0, and the mask is 255.0.0.0, and we have the 34 and 23. So 34 and 23. Okay, no synchronization. Exit. To configure the EBGP on this router 4 and router 5. Okay, so router BGP 65300, and we have the neighbor NEIGHBOR neighbor, and the IP address is 34.1.1.1. So 34.1.1.1, and the remote AS is 65300. No, 65200. 65200. Okay, and we have another neighbor, which is this router 5 is an AS65100. Okay, so neighbor 45.1.1.2, and the remote AS is 65100, and the network we are going to advertise is the Ethernet, which is 40. So 40.0.0.0, and the mask is 255.0.0.0, and we have the 34 and 45. So 34 and 45. Okay, no synchronization. Okay, now we configure the BGP on this router 5. Okay, so router BGP AS is 65100, and we have the neighbor, which is 45.1.1.1, and the remote AS is 65300. Okay, and we are going to advertise the networks, which is 50 dot and 45. So 50.0.0.0, and mask is 255.0.0.0, and we have the 45. Okay, no synchronization. Exit. Let's wait. The neighborship is up. Okay, you can see over here the neighborship is up. Okay, now let's verify the routing table of this router 1. Our main focus on this route network 10 dot and 50 dot network. Okay, so let me, okay, now and we are going to give the command show IP BGP. Okay, there you will see there is no 50 dot network. Okay, we have the 40 dot network, 30 dot network, 20 dot network, and it's local 10 dot network. Now on router 2, do show IP BGP. There you will see the 10 dot network, 20 dot network, 30 dot network, 40 dot network, and 50 dot network. As you can see over here, we don't have the 50 dot network, but router 2 has the 50 dot network in the routing table, because router 1 sees that its own AS number in the AS path attribute of AS65100. You can see over here. the AS path, AS path is 65100, and router 1 sees its own AS in the AS path attribute, so it refused this. This is the simple loop prevention mechanism of the BGP. Okay, now let's verify on this router 3. Do show IP BGP. You can see the 50 dot network and 10 dot network, all these networks, and router 4. Do show IP BGP. There you will see the 50 dot network, 10 dot networks, 30 and 40. Okay, now let's check our last router, which is router 5. Router 5 will also not accept this 10 dot network in its routing table because of the same AS. Okay, so do show IP BGP. You can see the 50 dot network, 20, 30, 40, but not the 10 dot network. Okay, so here comes the feature which is called BGP AS, allow AS. Okay, after we configure this feature, router 1 will accept and install the 50 dot networks in its routing table, and router 5 will accept this 10.1.1.1 network and install in this routing table. Okay, so let's see. Okay, first we configure the AS allows feature on this router 1 and then router 5. Okay, router BGP 65100, and we have the neighbor 12.1.1.2 allow AS in exit, and we write the command clear IP BGP soft. Okay, now same command we are going to configure on this router 5. So router 5, so router BGP 65100 and neighbor, which is 45.1.1.1 allow AS in exit clear IP BGP soft. Now let's verify. Let me minimize this router 5. Show IP BGP. Now you can see the 50 dot network in its routing table. Okay, the path is, the AS path is 65200, 65300 and 65100. Okay, now in the same way we verify on router 5. Okay, show IP BGP. They will see the 10 dot network and its path. The path is AS 65300, AS 65200 and then AS 65100. Okay, now let's ping. Okay, 10.1.1.1. You can see trace route 10.1.1.1. Okay, you will see the path. Okay, now verify from this router 1. Ping 50.1.1.1 and trace route 50.1.1.1. Okay, so I hope you like this video. If you like, please give a thumbs up, and thank you so much for watching this video. Thank you so much.